Hello students, now we are going to move ahead with electrostatic potential due to a dipole. Before that I will revise you what is a dipole. Dipole is nothing but two equal and opposite charges. Suppose this is q, then this will be minus q, and they are separated by a very small distance. Very small distance. Let us say the distance be a and a. So it will total distance is twice a. So what will be p? P is the dipole moment in vector form. It will be q twice a. Okay, this is your dipole. Okay, now what we need to do here, we need to find the electric dipole, electric potential due to this dipole. Suppose let us take here there is 1 minus q charge, here there is a q charge, and we need to find potential difference at this point. Let us say it is point m, or you can say any point. Okay, this electric potential is separated by a small distance, say L and L. Okay, this distance is L and this distance is L. Okay, now let us say this, the distance of this point from the dipole is x. Okay, now the electric potential at this point will be due to both the charges, one due to this charge and one due to this charge. Okay, so net potential, total potential on this point will be V1 plus V2. Let us say this is point 1, this is point 2. You can take any of them. Okay, so now what will be the electric potential due to minus q charge? It will be minus k q upon x plus L. Why x plus L? The distance here it is x and plus this much is L, so it will be x plus L. Now the electric potential due to this point 2, it will be plus kq upon x minus L. Will it be? Why x minus L? This total distance is x and this minus L has to be removed, so it will be x minus L. I hope this is very clear to you. Okay, now what we'll do, we'll take out kq common. It will be I'll write this first, 1 upon x minus L minus 1 upon x plus L. Okay, so we need to solve this. What we'll do is equals to kq, we can take LCM, x plus L minus x minus L whole upon x square minus L square. Okay, so what we'll write over here, kq, what will happen? Okay, I'll take one more step, x plus L minus x plus L. Okay, divided by x square minus L square. So what does this mean? This x will get cancelled. It will be kq twice L upon x square minus L. Okay, now do you remember this term, q into twice L? That is equals to dipole. Is it visible? Yes, it is visible in the camera. So it will be kp upon x square minus L square. So this is your required formula. Okay, I'll write somewhere once again. I'll write it over here. Your V net is equals to kp upon x square minus L square. Okay, this is your ultimate formula for the dipole on the axis. I forgot to write over here, on the axis. Why you can say it is on the axis? Because it is in the same line connecting this. Okay, it is on the axis of the dipole. Okay, I hope this much part is very clear to you. Shall I rub this? You can copy it down. I'll rub this portion. Okay, now what we will do here, we have already discussed dipole is separated by a very small distance, so value of this L and L will be very small compared to value of x. Okay, suppose say x is 5 centimeter and this is 5 millimeter. Okay, 5 mm, then it would be 10 raised to minus 8. So this unit would be, this distance would be very large compared to this. And again, if it is square, then square of 10 raised to minus 3 would be 10 raised to minus 6. So generally what happens, generally x is very much greater than L. If x is very much greater than L, then x square minus L square would be equivalent to x square only. Okay, can I write down? So V net would be equal to kp upon x square. Okay, so electric potential is directly proportional to 1 upon x square. Okay, Is it clear up till now? I hope it is clear. Okay, so the graph for this will be like we have already studied. It will be in this manner. Okay, SD, this will be X and this will be V. Okay, I hope this is very clear to you all. And let us remember what was the formula for electric field on the axis of the dipole. It was twice Kp upon R cube. Okay, or instead of R cube you can write X cube also. That was the distance. So when you compare this two, here it is directly proportional to the square of the distance, and here it was directly proportional to the cube of the distance. Okay, I hope this much part is very clear to you. This is the formula for general case. If here it is given that the distance L is also 2 mm or 3 mm and X is also 3 mm or 4 mm, at that time you can't apply this. At that time you need to apply this formula. Okay, I hope you have understood it. If you have still not understood, you can message me or tell me so that I can explain you in a better way. Hope you all are doing well. Thank you.